Let's build this game with Visual Studio WPF. Click in the description for a link to the source code for this project and a link to a full walkthrough of the extended version of this game called The Computer Dolphin's Dream. This game can give you an idea of what you could potentially build on top of this tutorial's source code. This extended game incorporates multiple levels, enemies, items, characters, and dialogue using the basics from this tutorial as a foundation. So let's get started. First, open up Visual Studio and create a new project using the WPF app.NET framework option. If we run this, it will initialize the component and that's it. Here we will find the window that's being initialized. One tweak we're going to do here is swap out the grid for canvas tags. All of our elements are going to go inside of these canvas tags. In the main window class, we will add two functions, setup game and start game. These functions will run when the main window initializes. In the setup game function, we're going to set up a game timer that will attach to a new function we're going to call game engine. This game engine function is what our game timer will run on every tick. We're going to set our tick interval to 10 milliseconds, so it will run the game engine loop every 10 milliseconds. The game timer's tick requires the function it's attached to have the sender and event arguments. And for our start game function, we'll simply just start the timer. So to see this in action, let's add a score box that updates every loop. First, let's create the text box, and in the setup game function, we can give it a background, make it read-only, and we'll set the initial text to score 0 and add it to our canvas. Updating the score every time the game engine function runs should have us updating the score every 10 milliseconds. I'm going to make a quick helper function here so we can use this update score function later to update the scoreboard. The function will update our score value and our text box. So if we run it, you can see that it's updating the score every 10 milliseconds. So let's use this loop to move two pictures from right to left. We'll start by defining two rectangles. Those will be our backgrounds, and we'll have two image brushes for the background images. For these background rectangles' height and width, I'm going to use the height and width of our main window. I'm going to copy the code for background 1 and do the same for background 2. Adding both backgrounds to our canvas, making sure to add it to the canvas before the text box so that the text box's z-index is above the background. In the start game function, I'm going to set the positions and I'm going to set the backgrounds to be side by side so that the background 2 will be pushed to the right the entire width of background 1. Also forgot to define the positions for the score text box, which I'll do now as well. I'm going to add two background images to our project, and these two images are the same image, but one is flipped. This will help with the infinite scroll visualization. All of these images and assets are available in the repo. So we already set the positions of our background rectangles in the setup game function. Now we will fill their backgrounds in the start game function. To set our background rectangles to these images, we will update our image brush's image source to the path of these images. We will pass in a URI that has a prefix of pack://applications:, which basically finds the project's root path that we can then direct to our images directory. Now, if we run this, you're going to see the first background and nothing is happening. That's because we need to move the background to the left on every game engine loop. So in the game engine function, we will have it call a new function called scroll background on every loop. And inside the scroll background function, we will move it to the left 1 pixel every loop. To move it, we have to get the current position and subtract it by the speed that we want to scroll. If we run this, you can see that it is scrolling both images side by side, but they just keep running off the page eventually. So we need to reset them if they go past a certain point. So in the scroll background function, we will check if they have completed their scroll and reset their location if so. Completing their scroll means they have completely gone off the screen on the left side. And if they have not, then we just continue to scroll them to the left. We reposition them to always be the width of the background on their left, and we add the scrolling amount. Let's put the scrolling speed into a variable as well. So now when we run it, we confirm that the next background gets replaced after it goes off screen, creating this infinite looping of the two images. So now all we need to do is add our actors. That includes our player, the rock obstacles, and the gemstones. We will first create a base class called actor that will hold these objects rectangles and image brushes, because we know that all of our actors will need at least those two things. The class will take in a height and width and initialize a rectangle and an image brush. Now let's make our other three classes that will inherit from this actor class. To make it simple, we will create a separate class for gem, rock, and player. We probably could use the same class for all of them and just have different constructor parameters, but this works too and allows for more customization between the classes in the future. Right now, we're just getting the template of all the classes set up. Our rock, gem, and player class will be exactly the same initially, but we'll have some slight differences soon. So in each class constructor, we set the initial image brush image, but in the player class, we're going to instead initialize a folder of images to choose from. Our player class will change the image every loop, so instead of setting the image in the constructor, it will set the array of GIF image files it will loop through. I'm creating an array of strings called imagesArray to hold the list of file names. After we drag that folder in, we can use the relative path of the Dolphin folder to get us the list of file names. So we're going to have our getFiles function get all the file names in this folder and save them into our images array. Then we make a function called Animate that swaps out the ImageBrush image consecutively. We create an index variable to keep track of the image that we're on, and we reset back to 0 when we reach the end of the images array. Then we can call the Animate function in the game engine loop. So let's create an instance of the player and set them up and run their Animate function. In setup game function, we will initialize them and add them to the canvas. One thing to note is, as you can see, we could have made the backgrounds into class instances as well. So this is just showing you two ways you can organize your code. And in the start game function, we will set the player instance's initial positions. So let's try testing it without running the animate function and just instantiating the player class first. Without the animate function running, we see nothing because we did not set any initial image. Images only get set in the animate function. So let's add a call to the animate function in our game engine loop. You can see here I forgot to add the image files to the Dolphin folder. And now I only see the tip of the dorsal fin, so let's check our position. Run it, and now we see the images changing. Let's add an instance for our other two actors, the rock and the gem. So just like the player instance, we will initialize and add them to the canvas in our setup game function. We'll give the rock a bigger height and width, and we'll give the gem a smaller height and width. And we will set their initial positions in the start game function. I'm going to set the rock and the gem to the far right off screen. After running that, we won't be able to see the rock and the gem unless we update them in the scroll function, just like how the background scrolls. So let's update our scroll function to handle the gem and the rock. Just like the background, we will move it to the left, or if it goes off screen, we will reposition it on the right. We'll do this for both the rock and the gem. Running this, they should all be scrolling the same speed, and repositioning should be working. And I'm going to speed up the playback. Let's give them different speeds. We will keep the rock the scrolling speed, since it needs to seem as though it is part of the landscape. The gem, we will make it go faster. Okay, so now the gem is going faster. Let's randomize the top position every time the rock and gem reposition themselves. So we'll create a function to generate a random new position called reset position. We will have it randomize a new position from the right off screen between 0 and 300. We do need to create a random number generator, and we can initialize that in the setup game function. We will reset the top between 0 and 100 less than the height to make sure it's always visible. We can use this in the setup too now to initialize a random position for the gem and the rock. That way the game will always start with the gem and the rock in a random top position. I'm going to speed this up. The rock and the gem both reposition randomly every time. Good. Let's also update the code to make the rock change sizes too. Okay, now for the best part. Let's make the arrow keys move the dolphin. Back in the main window, let's add some key events for when we press a key down and when we lift a key up. We will name our key down function canvas key down and our key up function canvas key up. Just like the game engine function, we need the sender and event arguments for key press functions. We're going to handle the right, left, up, and down arrow keys. So to make our controls work so someone can be holding the up arrow and then press the down arrow and have the down take priority, we have to get our logic right. I like to set the directions as ints and add onto the complementary variable to see which one was clicked last. So in the player class, we add 4 ints to track these movements. It also helps to set it up this way in case you later want to have specific images displayed when pressing specific arrow keys. So when we key up a certain direction, that means we reset that key and make it equal to 0. But when we key down, we add 1 to its opposite direction. Left equals right plus 1, up equals down plus 1, etc. So if left is 0 and we press right, then right will be 0 plus 1, which gives us 1. And we know that 1 is larger than 0, so we want to go right. But what if we were holding the left key down and then pressed the right key? The left key would be 1. So our right key would then be 1 plus 1, giving us 2, and 2 is larger, so we would still move right. Therefore, the last key pressed always takes control. For these key presses to be used, we need our game engine loop to handle what happens when these values change. So let's create a function called handle key presses that we'll call in our game engine loop. In this function, we will get our current position and a new position. Then we'll check our ups and downs. If our up is more than our down, we'll go up, and if our down is more than our up, we'll go down. And if no up or down were pressed, we will have a default falling, so we will still update the top position. We'll set the vertical speed to 3 and the falling speed to 2. We will do the same logic for the left and the right since those are opposites. And we'll set our horizontal speed to 4. As you can see, the if-else statements allow for changing the vertical and horizontal positions at the same time, which means you can move diagonally too. Then we will set the updated position and when we run it, we have control over the arrow keys. To make sure the dolphin stays in the screen, we will only move the dolphin if it stays within the bounds. So I'm going to update the code to only set the position if they're in the bounds. We do this by only updating the position if the new top is between 0 and the height of the screen, and if the new horizontal position is between 0 and the width of the screen, also accounting for the height and width of the player. Now I can hold the arrow keys and no matter what, I won't go off screen. Now let's add some logic for when the dolphin collides with the rock and the gem. So let's create some hitboxes using rect. To check for collision, let's create a new function that is called in the game engine loop called check collision. In here, we will set our rect hitboxes to match our object's rectangle's positions and check if they intersect with each other. Here, I'm defining the player hitbox to be the exact position and size of the player's rectangle, and I'm going to do the same thing for the rock and the gem. So when we intersect with the rock, we will end the game. And when we intersect with a gem, it will update our score and reset the position of the gem. For the endgame function, let's give our player a red border. By default, it will be a thickness of 0, and when we die, we'll increase the stroke to 1 so it's visible. We'll define the stroke color in our player class, and then in our start game function, we'll set the stroke thickness to 0 so it's invisible. And set it to thickness of 1 in our endgame function. And let's create a boolean for game over. Let's check this game over variable in the game engine loop, so it stops running the game when the game over is true. Let's test out our game over red border box logic now. Okay, so our red border and game over logic work, but our score is still incrementing every loop, so let's stop that, and let's add another key press event for when game over is true. So if the user presses start and game over is true, we can restart the game. By checking for game over to be true, this prevents us from restarting the game every time we press enter. So if we run this, we are incrementing the score when we hit the gems, and when we hit the rock, it's game over. Looks like I forgot to reset the score in start game as well. As you can see, it's actually the score text box that I forgot to update. Now our restart logic is working right. Lastly, let's add a box that pops up when you die to instruct the player to click enter to retry. We'll set the end screen text box very similarly to the score text box, but we'll add a border to this one. And we'll add it to our canvas. Let's set the position. By default, it's invisible, and when game over is true, we set it to visible. I'm also going to center it on the screen so it's not on top of the score. And that's all you need to get the basic function working for a scrolling game. Thanks for watching, hope this helped, and have fun!